Previously, the Internet of Things was the last big thing which boasted and touted the interconnectivity of all things. In 2022 now, the metaverse is the next big thing with much broader concept than just virtual gaming. Most VR simulations only focus on the visual and acoustic as feedback to the user. However, multisensory experiences is the main key idea of the metaverse, where it involves different sensory channels such as visual, auditory, as well as haptic. Thus, wearable that can mimics the feeling of handling real objects in the virtual world, such as haptic gloves, are gaining more and more attention. Many of the creators have proposed their haptic gloves solutions, such as Lucas built a haptic gloves by himself with just $60. He developed a wrist-based haptic interface using the Arduino microcontroller and Leap motion sensor. However, the use of Arduino in the system is a significant drawback, which makes the wearable system bulky and not user-friendly. Moreover, the ADC used in an Arduino is successive approximation register type. In applications such as haptic glove, an ADC with higher conversion rate is preferable. Thus, a flash ADC is better in this application in terms of speed. However, a conventional flash ADC have the drawbacks of high power consumption and relatively larger size. Therefore, our solution is to design a low-power flash ADC and keeping the size in minimum as possible. Conventionally, a 4-bit flash ADC contains 15 comparators, 16 resistors, and 1 priority encoder. We proposed a 4-bit flash ADC that contains only 3 multiplexer and 4 modified comparators. In flash ADC, the operational amplifier is the most energy-consuming component. To minimize the power consumption of the operational amplifier without compromising the performance, current subtractor circuit was implemented into the design to make the current separate into different branch when operational amplifier is in its operation. Thus, minimum current required will flow to the output. As we know, power equals to voltage times current. As the output current is lower, the output power consumption will be lower as well. We validated our idea in 130 nanometer technology by using Mentor Graphics EDA tool. At a working frequency of 100 kHz, the result turns out the proposed flash ADC consumes 33% lesser power if compared to the conventional flash ADC. The improved flash ADC functions well with lower power consumption. Hence, the idea of adding current subtractor into the comparator to reduce the power consumption is validated. The improvement of the ADC in haptic glove is believed to improve the realism in the VR environment and serve as an effort in the metaverse concept. A more realistic touch sensations in VR will benefit a wide segment of industry, such as medical industry. According to a study, they found out that with the combination of 3D and haptic feedback, the skill acquisition of the medical students is 32% faster if compared to the 2D learning. With the redesigned low-power ADC for haptic feedback in VR, and along with all the efforts made by engineers from all around the world, an improvement in the haptic gloves would make a huge difference in making the metaverse more immersive.